Conjecture is a guess based on observation. It's kind of like a hypothesis. Be careful because you can observe a pattern and the pattern might not hold for all values. It might only hold for a small set or even a very large set, but it might not hold for all values. So for instance, people who are first learning about fractions will often believe, and of course, you cannot do this. This is obviously not true, but it's an idea that people often have at the beginning. This is kind of obviously nonsense, which is like I could just go around canceling things that are written next to each other. That doesn't work either, does it? Equally as bad. Then every once in a while you get something that does kind of look interesting. For instance, if you look at 16 divided by 64, it turns out that by a miracle, you can cancel the sixes and you get one right answer. These are called digit canceling fractions, and they do exist. And I saw a cool one today. Someone pointed out that if you start with 2666 over 6665, and you cancel a pair of sixes from top and bottom, and then you cancel another pair of sixes, and then you cancel another pair of sixes, and in fact, all of these intermediate cancellations are correct as well. We're going to define a function from the integers to the integers, and it's going to be a piecewise function. So if n is even, then we can divide it by 2, and we do so. And if n is odd, we can multiply it by 3 and add 1, and we do so. And what would C of 1 be? Since 1 is odd, C of 1 would be 3 times 1 plus 1, which is equal to 4. You buy this? What about C of 5? I heard 16 because 5 is odd, so it's 3 times 5 plus 1. And on the other hand, we can evaluate C of 2. 2 divided by 2, which would be equal to 1, or 8 divided by 2. We can evaluate this function on any integer, because for any integer, it makes sense to look at n divided by 2 if it's even, or 3n plus 1 if it's odd. So let's look at what happens if we keep repeatedly applying the C map to whatever we start with. If we look at C of 1, we get 4. If we look at C of 4, what do we get? C of 3. 10, and then C of 10 is C of 5 is okay, and C of 16 is C of 8 is, and look where we're going. So we're in that 4-2-1 cycle. C of 12 would be 6, and C of 6 would be 3, and we already did C of 3. And we found that when we started with C of 3 equal to 10, that we traced this down and we ended up with a 4-2-1 cycle. So this is called the Collatz Conjecture, after the mathematician who popped. And the point is, for every number that has ever been tried, you end up in this 4-2-1 cycle, up to humongous numbers. I don't know what the biggest Collatz number that's been tried is, but they've computed very, very large number. It's still not considered proven. Because how do we know there's not some super humongous monster number that we haven't tried yet that escapes this behavior? I think the question is, why are some things easy to prove? Because in reality, if you just pick a random math problem, it's probably going to be hard to prove. So why are some things easy to prove?